Okay, students, we're going to talk about arc length here. And remember, arc length is a distance around a circle, a fraction of that distance. So if we're in degrees, we know there's 360 degrees in a circle. If we're in radians over here, there are 2 pi radians in a circle. Okay? All around the circle is 2 pi. Okay? Don't forget you got 0 here, 90, 180, 270, 360. Well, this 180 degrees is pi radians, so half of that would be pi over 2. Another half would be 3 pi over 2 past the pi, and of course double 180 is 360, so there's where you get your 2 pi radians. Okay, so let's say they go ahead and say find the arc length of this right here. And here's the center. Let me tell you this is 5. And they give you this, and they tell you this is 150 degrees. Okay. Well, the formula that you have to memorize, because the DCAS does not give it to you, is, remember, it's a fraction of the circle. And since it's in degrees, it's going to be x over 360. Okay. Versus if it's in radians, the fraction of the circle is x over 2 pi. Full circle is 2 pi. And distance around the circle is called circumference, and the formula for circumference equals 2 pi r. So we just add on the 2 pi r right here, and 2 pi r right here. Okay? So we have that. Move that up there. So we just fill in this 150 degrees into the x over the 360 times 2 pi, and we know what r is now. Fill in the 5. Okay? And we do our calculations. We're doing our head, you can cancel the zeros there. Okay? 2 goes into 36 18 times. Well, 3 goes into 15 5 times. 3 goes into 18 6 times. And we have no other cross canceling or vertical canceling. So we have 5 times 5 is 25 pi over 6. That would be the exact length and wherever the units are. Degree 1, because it's a straight distance. Okay. Now, let's say we do the exact same thing over here. Okay, but instead, they don't give it to you in degrees, they give it to you in radians. Okay. And they say they either will put the 5 pi over 6 right here at the central angle, or they might put 5 pi over 6 right there. We'll use the same radius, 5. So we're going to see that we'll get the exact same answer. Okay, well, again, the reason I'd use this formula is because it's given to me in radians to begin with. If it was in degrees, I'd use this formula. Okay, so you want to know both of them. Now, look what happens right here, though, in this formula. Doesn't the 2 pi and the 2 pi cancel? So all we do is do r times the x is often called theta, the angle measure. Theta, remember, is always an angle measure. So arc length equals r theta, where theta is in radians. So you see how easy this one is, because we know the r is 5, and we just multiply it by the 5 pi over 6. And what do I get? I don't have room to put the answer over there, so I'll put it over here. 5 times 5, 25 pi over 6. The exact same answer as we have right there. Okay. Now, if, for example, you didn't like working in radians and you want to change that radians to degrees and just use this formula right here, I have to first convert the radians to degrees. To convert radians to degrees. Okay, I'm going to have, as we have there, 5 pi over 6, so that's my radians, times pi in the denominator because it needs to cancel with the radians in 180 degrees in the numerator. Now, why is that? Because 180 degrees and pi are equal. What's any number divided by itself? 1. So this really is like saying 1. So now I get that canceled with that. 6 cancels with 180 degrees 30 times, and 30 times 5 is 150 degrees. Exactly what we have right here. Okay, so then I could take that and plug it into that formula we already did right above and get the same answer. Okay, so now you've seen an example both of how to find arc length and if you're given degrees, and another one if you're given radians. And if you didn't like radians, how to convert from radians back to degrees. Okay, now we're going to talk about areas of sectors. Okay, in both degrees and radians. Degrees and radians. Again, okay, you might see one problem perhaps in radians on the DCAS. You may or may not see it at all. So I'm just exposing it to you just in case. Okay, you're going to have a practice on your assignment. Okay, so you see that. So let's say they have, that would have been center is better right about there. Okay, let's say this is 135 degrees. Okay, shaded in. They might put the 135 degrees outside here instead. Okay, and they have it shaded all in like this. Okay, that's often what they'll probably do when it's area of a sector. Okay, so again, it's a fraction of the whole area. So a fraction, and then we're in degrees, 360 degrees in the whole circle. Now it's the area of the circle. Area of a circle you need to know from middle school is pi r squared. Let's say they give me this radius is 6. Okay, so now I go ahead and plug in the degrees, 135 degrees over 360, pi 6 squared. So 135 degrees over 360 times 36 pi. Well, notice the 36 will cancel with this one, you're left with 10. Okay, well now I can divide each of those by 5. 5 goes into 135 27 times, and 5 goes into 10 2 times. I get a pi left over for the numerator. So it's 27 pi over 2. Okay, well let me give you that same thing in radians. So instead of, they have it all shaded in for you, okay, and it's all shaded in. And instead of giving it in degrees, they give me in radians, which is 3 pi over 4. Okay. By the way, I will show you how you can get that 135. I want to go convert degrees to radians. So on the last page, we did radians to degrees. Let's say if you want to work into radians instead, we're converting 135 degrees. Okay. So that means I need to have the degrees in the denominator, so the degree sign symbol out, and 180 degrees equals pi. Okay, so it's just the reciprocal of the other one. So then the degrees cancel out, and 135 over 180, 45 goes into each is the GCF, and you get 3 pi over 4. Okay, which is why then I have 3 pi over 4. Okay, so now don't forget we're doing 3 pi over 4 divided by 2 pi times pi r squared. The r was 6. Okay, so you should know that you can drop that down there. So I really have 3 pi over 8 pi times 36 pi. Well, those pi's cancel out. 8 and 36, 4 goes into 8 twice. 4 goes into 36 9 times. Okay, and I get, therefore, 27 pi over 2. Okay, and isn't that the exact same thing I got over there? Same answer. Okay, so that's how you can leave it in radians and still work it. Again, if you don't like that, you could take the 3 pi over 4 and multiply by 180 over pi, and it would convert back into 135 degrees. Okay, so now the reason I want to go over that is because, again, common missed problem on the DCAS is both of these, area of sector and arc length. Okay, and I think a major reason why is because the students don't have their formulas memorized. This is not given to you. Okay, so remember, this one would have been x over 2 pi times pi r squared that I filled in. Okay, so if it's in pi, you're going to leave it in pi. In radians, it's out of 2 pi. That's the full circle. If you're going to use degrees, it's out of 360. The rest of it is the same. Okay, that's the only difference. The denominators are 360 if you're in degrees, or 2 pi if you're going to use radians. Okay, that'll do it.